Hi, I am going to go through the steps that I used to set up my lab safety breakout, and hopefully it'll all make sense once I get through it. A couple things I've changed since writing it, so I will include those new things so that they make sense, or at least I hope they make sense. So first of all, I have my breakout box. So I made my own because I just didn't have a chance to order one yet. So there's my breakout box. Inside my breakout box, I have the Flynn Lab Safety contract for my students to read and sign when they are done. I have my combination lock, my hasp, my word lock, my key lock, and my number lock. So I also have my lockbox, which is set to 110, and inside that lockbox I have a light, a UV light. So also, to set up, I have a few other things. I have a letter to my students, and I'm also going to put in that letter the visible spectrum of light. I have, one second, a quiz that the infamous Dr. Jekyll failed miserably. And this quiz is based on a website the students will have to go to in order to get a code out of the answers to unlock the 4-digit lock. That'll be on a clipboard around the room. I have my lab safety tip flyer that I made. There's a little arrow pointing into here to show, with the UV light, to show that that Erlenmeyer flask is important. I have this worst lab accidents in history lecture flyer that the students will get the website to answer the questions for that quiz. I have my hint cards, and then I have a few other things. So I have 4 Erlenmeyer flasks that have been filled with water that are colored with red food dye. And to label these flasks, I'm going to put a card in front of each one. And each card has a different name of a bacterium, and then it just says, this one says Pseudomonas aeruginosa in nutrient broth, do not dispose of until, and the date is after the breakout. So students don't think they can just take this and pour it out, because one of them actually has a key in it. Let me get that one for you. So in this particular one here, and you can't see it right now because it's inside, but the key, the lock, key lock, is in a baggie, a sealed baggie inside of this, and there's a magnet attached to that key to make it metallic, or magnetic, so that you can just use a magnet to bring up the key, and you don't have to pour anything out, and that's going to be important for the students. In a lab coat that I'll have hanging up, I have my lab goggles. I have in here a magnet that actually looks like a pen, but is actually a magnet. And in the other one, I have my flash drive. On that flash drive, you'll find a personal journal, not the teacher's lab journal, but a personal journal to talk about her experiences with her new lab assistant, who's actually absolutely horrible at lab safety. And then she realizes that what he's actually going to be doing is trying to steal her research for horrible means. So they're going to need to find that flash drive by looking at the letter and seeing that she recommends that she left information for them in something she uses every day. And so hopefully they'll realize that the lab coat is important in that way. Let me just show you how the magnet works. So you have to, I've discovered that this magnet's not the strongest. So you have to make sure the magnet is very close to the edge of the glass. So hold on a sec. Sorry. So just to make sure of that, I'm gonna kind of force that over there before the breakout starts, so that then I can just basically, oh, why aren't you working? You worked yesterday. This is why we do experiments. There we go. I'm going to have to force out a little bit more. And so we're just going to bring up the key. And students are going to probably have a hard time doing this at first. I'm going to leave some tools there for them to kind of, like a skewer to push it over. And once they have it up to a certain point, they're going to be able to, and they can even move it just like that, they're going to be able to get that key out just by grabbing it. And again, this is just food coloring. I also have another stronger magnet that I might leave nearby, just so that they can for sure get this out with no problem. And they'll have to figure out which one of those flasks actually has the key. They'll be probably a little distracted by the labels in front of them, so they won't be as obvious. So that's that. Also, for the directional lock, we have a little bit more challenging task. So what they're going to have to do, because the visible spectrum is going to be in their letter as a clue, they're going to have the visible spectrum, and they're going to have to check out the wavelengths of each color to find the correct order of color in these flasks. So I have red, obviously, yellow, green, blue, and purple. And underneath, I don't know if you can see it, but underneath I have directions. I'm not sure if I'm going to leave them there, if I'm going to just put little arrows in the front. That'll be a little more obvious, but maybe not. So I'd like to keep it a little bit more, mysterious. So on the board, I'm going to have some equations that are based on the periodic table. And so here I have 5 equations numbered 1 through 5 to show which one would go first. The first one I have iodine times neon. And if you take the atomic number of iodine times the atomic number of neon, you end up with the first wavelength, which is for green. It's 530 for green. So that'll be where the students will have to say, okay, that one comes first. That direction will be first. And then the next one I have vanadium times calcium. And vanadium, the atomic numbers of each one of those multiplied is 460. So that means blue will come next. So whatever direction is under the blue will be next. The next one is red. We have parentheses cesium plus promethium times carbon. And then we have magnesium times tin for yellow. And then I have calcium squared, which is 400 for purple. And students will have to use that and understand they're going to use that for the directional lock. What else? The lockbox lock, they can get that information directly from the journal because it refers to the day that their instructor hired Dr. Jekyll, which she goes on about how it's the absolute worst day of her life. And also the word lock is based on her bird's name. So her bird, she talks about in her journal quite often as her beloved bird Polly. And so the word for the word lock is Polly. And on a flyer in invisible ink, we have written these locks are for the birds. And so hopefully that will give them a little clue about that. And again, I already described this, but just to reiterate, the quiz will be sitting in the room and Dr. Jekyll's already taken it and he's gotten them all wrong. And the students will have to figure out what the right answers are and then realize they have to go from letters A, B, C, and D and translate that into 1, 2, 3, 4 for the lock. So instead of, that they'll have B, I think it's B, C, D, C, which will be 2, 3, 4, 3. And that, I think, is it. At the end, the students will find their lab safety contract, and they'll be ready to start the school year with lab safety. So I figure this is a really good way to get students to start talking about how they collaborated together, how they worked people who didn't work, maybe they didn't learn as much throughout the experiment, the breakout. Maybe they learned a bit of lab safety at the same time instead of me just talking about it to them. So hopefully this is fun and it goes over well and you have success with it as well. As far as the magnet goes, I think, so you can see that the baggie is quite large. I'm going to look for a smaller baggie because I think it's hindering the key in general. So, but I don't want to put the key in by itself because just a key sitting in water is not the best idea. So I'm going to have to find a smaller baggie for that. Thank you very much for watching. I hope you have success with it, and I'd love to hear about how it went or if you made any changes that are exciting. Thank you. Bye.